This is Mrs. O'Neill for Chapter 10, Section 2, Part 3, Two-Step Mole Problems. We want to remember that there are only 3 conversions and everything equals a mole. But how about if you wanted to go from particles to liters? That's where this mole island comes in very, very handy. So notice how I added those alligators. So let's say I wanted to go from gram island to volume island. So they gave me a mass amount and I want a liter amount. Well, notice here, I can't go that way. I can't go that way because those alligators would eat me up. So what happens is I have to go through the bridges. I have to go from mass to mole and then mole to volume. So I know those conversions. I know the conversion from mass to mole and mole to mass. And again, everything equals 1 mole. So we cannot deviate from mole island. We cannot deviate from those bridges. Same thing if I want to go from mass to particle island. I can't do that, especially because of those alligators. I have to go from mass to moles and then from moles to particles. How about if I wanted to go to volume to particles? So I say I have 80 liters of hydrogen gas and I want to know how many particles that would represent, how many molecules. Well, I can't just go in one fell swoop. All right, again, those alligators are out to get me. So what happens is I know the conversion from volume to moles and I know the conversion from moles to particles. So that's why I call these a two-step problem. So I have a bunch of examples here. We'll go through them. Like I said before, you might want to listen to everything first and then pause the video to write them in your notes. So example 1, how many grams are in 4.24 times 10 to the 68 atoms of gold? So my first thought is I want grams. That's my question mark. Now, where am I going to start, however? Well, I look at my number and the unit right after it tells me that I'm going to start at particles. So in my head, I'm going to go from particles to moles to grams. That's why it's a two-step process. So we're going to start with my number over 1. I'm going to multiply it by my line. As always, what unit goes on the bottom? We always want to think units before numbers. So what unit's going to go on the bottom is atoms. Again, because it says atoms of gold. I'm going to go to mole island first. Now, what number always goes with mole? 1. We learned that before. And what number goes with atoms? We need to think about that Avogadro's number. But we're not done yet, right? If I cancel out atoms here, I'm not going to be left with the gram unit that I want. I'm left with the mole unit. So multiply by my line. Again, this is going to be that two-step problem. I need that extra step. So I'm going to, again, put moles at the bottom. Think units first. I'm going to now put grams. Uh-oh, grams. At Gram Island, we don't have a true value. At Gram Island, we have to come up with that molar mass or the atomic mass or the formula mass. So what substance are we dealing with? Well, gold. So let's get that symbol of AU. We're going to need to pause the video and we're going to need to get out that periodic table and we're going to need to find the mass of AU on that periodic table. So when we do that, we find it to be 196.97. Remember, this really represents 196.97 grams per mole. Or we could say for 1 mole, we have 196.97 grams. So remember, we're going to now use that in our conversion. So what number always goes with mole? 1. And now that we know the mass of our gold atoms, now we can put that in there. So at this point, how are we going to put this into our calculator? Well, like I've said before, we're going to, I think this was way back in the beginning, the very, very first video notes that we did when we just did a bunch of conversions all at one time. This was the reason why we did that. So we're going to divide, then multiply, divide, then multiply, then equal. Oh, sorry, then divide, and then equals. But you should do it in order. So at this point, pause the video, get out that scientific calculator, remember to use that magic EE button, do the mathematics, and see if you come up with an answer. Hopefully you paused the video, you plugged and chugged, you used that EE button on your scientific calculator, and you came up with 1.39 times 10 to the 47th grams of gold. And again, your calculator might have an E on here. We never write the E. We always do times 10. That's the proper way of writing scientific notation. All right, pause the video and write this information in your example 1 in your packet notes. Let's look at number 2. In 300 grams of xenon gas, calculate the number of liters at STP. Remember, when we're dealing with gas, we can be dealing with liters, and STP is standard temperature and pressure. Those are the conditions at which that measurement was taken place. So what do I want? We want liters. Where am I going to start? I'm going to focus on that number, and the unit afterwards is grams. So that's going to be my starting point, times my conversion line. No matter what unit goes on the bottom? Grams, because I want to cancel that out. What's going to go on top? Well, if I look at Mole Island, I do not know the conversion to go from grams to liters, but I do know how to go from grams to moles. So that's going to be my conversion. At Graham Island, I need the mass. So I'm going to find my symbol for xenon, which is Xe. I'm going to look at that periodic table to find its mass of 131.29. Now I can put in my numbers, my corresponding values for my conversion. 1 always goes with the mole, and now I can put my 131.29 grams down there. But I'm not done yet, because I don't want moles as a unit answer. I want liters. So multiply by a line. Again, moles goes on the bottom. In this case, I want to go to liters, and I have that conversion, moles to liters. The 1 goes with the mole, and the magic number that goes with liters is always 22.4. So again, in the calculator, we're going to divide, we're going to multiply, we're going to divide, we're going to multiply, we're going to divide, and then hit that equal sign. So pause the video and do the mathematics in your calculator. Hopefully you paused and got that as an answer. All right, on to example 3 after you pause and write this in your packet. Number 3, how many formula units are in so many grams of aluminum hydroxide? Now I'm going to go a little quicker, guys. So I want formula units. I'm going to start at grams because that's where my number is. So I'm going to start setting up the problem. Times my line. Grams on the bottom, moles up top. I don't know what that value is, so I need to first find the formula for aluminum hydroxide. Aluminum and hydroxide, and crisscross my charges. Then I'm going to use my periodic table to figure out the mass of 1 aluminum, 3 oxygens, and 3 hydrogens, and then add those all up. So why don't you pause the video and see if you can come up with that formula mass. Hopefully you came up with total 78.01. Now I can put in those values. 1 always goes with the mole, and my mass is now going to go on the bottom. Not done yet, so I'm going to multiply by my line. Again, hence the 2-step problem. Mole on the bottom and formula units up top. So the 1 always goes with the mole, and that formula units is really a particle. So those particles are represented by Avogadro's number according to Mole Island. Again, I'm going to divide and multiply and divide and multiply and divide and equals. So pause and see again if you can use that magic EE button and come up with an answer. Hopefully you paused and came up with 4.39 times 10 to the 23 formula units of aluminum hydroxide. Pause and write this in. Next, calculate the liters for 8.9 times 10 to the 63 atoms of xenon. Here we go. So I want liters. I'm going to start at atoms. So start my conversion times my line. Atoms on the bottom, moles up top, because that's the only conversion I know. I know that if I'm dealing with atoms, I'm really dealing with particle island. So 1 goes with mole, and that magic Avogadro's number goes with atoms. Times my line. Moles again goes on the bottom because I want to cancel out that unit, and liters goes on top. Woohoo! I don't even have to worry about what the substance is because for here, I know that 1 goes with the mole and 22.4 goes with liters. Hence, I don't even need the mass for this particular problem. You're not going to always need to deal with the mass, only when you're dealing with Graham Island, either going from Graham Island to moles or moles to Graham Island. So again, we're going to do our mathematics. Divide and multiply and divide and multiply and divide and equals. So pause and see if you can come up with an answer. Hopefully you paused, again, using that magic EE button and come up with that answer. Pause now and write in the work in your packet so you can always refer back to it. Number 5, in 5.25 times 10 to the negative 45 liters, again at STP, very important for the mole concept, there are this many molecules of hydrogen. All right, so here we go. I want molecules and I'm starting at liters. So I'm going to start setting up my problem. Times my conversion line. Liters goes on the bottom, moles goes on top. I'm going from liter island or volume island to mole island. 1 always goes with mole and 22.4 always goes with liters. Multiply my line. Moles goes on the bottom to cancel out. And in this case, I'm looking for molecules. Ooh, again, no need for the periodic table, no need to come up with the formula, and no need to come up with a mass for hydrogen. 1 goes with the mole, and Avogadro's number goes with molecules. Again, the mathematics. I know I'm repeating myself, but I want to make sure that you're understanding how to do the mathematics because it's going to be important later on. Divide and multiply, divide and multiply, divide and equals. Pause and see if you come up with an answer. Hopefully you did. Hopefully you came up with that many formula units or particular particles or, oops, oh, Mrs. O'Neill did a mistake here. Formula units is not correct, right? It's a molecule, right? Because hydrogen is a diatomic molecule. So we want to change that unit there from FUs to molecules. So make sure that you're understanding, right? Each of those particles are represented by a particular number or particular unit, I should say, a unit that represents what kind of substance it is. All right, on to number 6. Calculate the mass in grams of 172.33 liters at STP of carbon dioxide. So I want mass. We're going to start at liters. So here we go. So there's our starting times our conversion line. Liters on the bottom, moles up top. That's the only conversion I know. So 1 goes with the mole and that magic 22.4 goes with liters. Again, that you've dealt with. Now we're just putting it into a different, the first step of a 2-step process. Times our line, because I don't want moles as an answer, so I'm going to definitely put that on the bottom because I want to cancel that out. And I'm going to be grams up top. If I want grams, I need to think of formula mass. If I want formula mass, that means I need the formula of this substance. So carbon dioxide is CO2. Pause the video and see if you can come up with a mass for carbon dioxide. Hopefully you paused, you came up with 1 carbon and 2 oxygens, adding those together to get 44.01. So again, the 1 is now going to go with the mole. And the 44.01 goes with the grams. Yep, you guessed it, the mathematics. Divide, multiply, divide, multiply, divide, and equals. So pause the video, see if you can do the mathematics and get the correct answer. Hopefully you paused, you plugged and chugged, and you got 338.58 grams of carbon dioxide. Again, since mass is in the problem, I know that I'm going to need the formula mass or the molar mass of my substance. All right, hopefully that makes sense. And again, we'll have more practice the next video. And we will go from there, have a discussion also in class.